And hello everyone, welcome back to another C++ tutorial. So in this tutorial we'll be taking a look at smart pointers. Alright, let me just get rid of all of this reference code. Now first of all, since we want to work with smart pointers, we need to include, and this will allow us to work with smart pointers. So you might be wondering, what exactly is a smart pointer? What makes it smart? Well, these are pointers you don't have to delete yourself. They will delete themselves automatically. So generally when you create a pointer, you have to delete it yourself after you have created it. Currently we haven't really been doing that in these tutorials because we have been looking at the basics, but usually if you create a pointer you have to delete it later. For example, int I is equal to new int, and then you have to delete I. You have to do this once you're done with the pointer. Otherwise that pointer is going to stay in memory, and as long as that pointer stays in memory, you cannot use anything else in that memory location. So if you have 1,000 pointers in memory, that means 1,000 places in memory. So let's say all of them were integers. That's like 4 bytes. 4 times 1,000, that's 4,000 bytes. So that all that space in your RAM can no longer be used until you reboot your system, because those pointers were created but never deleted. A smart pointer will delete itself. Generally, it is recommended to use a smart pointer before you try and use one of these pointers. Because of these pointers, they can be more difficult to manage. So let's talk about the two types of smart pointers we are going to be talking about. We have the unique pointer and the shared pointer. The unique pointer are just scoped pointers. So when it goes out of a scope, it gets deleted. You cannot copy a unique pointer, so take that as note. That is why it's called unique. So it's unique, and once it goes out of scope, like let's say you have a function, once that function call is over, it's deleting itself because it's in that function scope. And then you have a shared pointer. This is a smart pointer that you can have multiple of. So it will automatically create itself, it will call the new keyword, and it will automatically delete itself. However, unlike with unique pointer, you can have multiple of these without any problems. So to create an example, let's create a class person, and this person class will have no private items. It will have a constructor person, and this constructor will just create a cout person was created. Then we can have a destructor that just sees out person was destroyed. Because generally we know by now that when you create a constructor, it basically runs before the rest of the code runs in this class. It is what starts everything up. And a destructor is what ends everything in the end. And then let's create one extra function here, just so we can see an example. Void say hello. And this say hello function will just say, hello there. There we go. Oh, let's just remove these. Cool. Let's start off with a unique pointer. So just to create a little scope, you can either create a function or you can just do this. This will automatically create a scope in C++. So anything between these is a new scope, or is in this scope. So once it goes past this here, whatever is in here will be deleted if it's not part of global scope. Cool. So you have two ways to create a unique pointer. You have the first way, which is std : unique pointer, and you specify what you want to create a pointer of. So in this case, person. This is our object we want to create a pointer of. Person is equal to, or here you don't need an equal, you can just say person, and then new person, like this. You can use this. However, it is not really recommended to use this method. Primarily because, in general, smart pointers calls the new keyword for you. So when you do new person here, you're kind of missing a nice function that smart pointers gives you. So you don't have to use new. Instead, what is recommended is that you go std unique pointer person is equal to std make unique, and then you specify the type person, and then there you go. You have just made a unique pointer where this is what you are pointing. This will automatically call new for you, and at the end call delete. This is also recommended because this way it's safer if an exception occurs. With the previous method, if an exception occurs, then you might sit with an empty pointer, so a pointer without a reference, which will generate a memory leak, which means that everything we have just explained, there's a place in memory that is now filled with a reference to something that doesn't exist, an empty pointer. And here we can just say person, say hello. Let's try this out. I'm going to compile this and run it. Person was created. Hello there. Person was destroyed. So it created a pointer to this person object, and then it destroyed it after this. Now let's say we created a pointer without this safety in it. So person is equal to new person. Okay, there we go. Now let's try and run it. We get person was created. Hello there. The program finished and we did not get a person was destroyed. So there is a little bit of a memory leak here because now we have this object, this item in our memory, but it's not being used. To fix that, if we used normal pointers here, we had to go delete person and then run it again. But smart pointer kind of removed the need for that. So now we can remove this creation here and that delete, and we just do this. It will call new and it will delete it for us. Cool. Now let's take a look at shared pointers. Now, unlike the previous pointer, we should never actually do std shared pointer and then the type person and then person new person. This is still okay with a unique pointer, but with a shared pointer you should never ever do this. Instead, you should use the method we used previously, where we have std shared pointer person, and let's call this person 1 because we might want more since this can be shared, is equal to std make shared and then our person, and we are good to go. This is perfect. Now it will delete itself, it will create a new one. Now the nice thing about a shared pointer is it can be shared amongst other shared pointers, so multiple shared pointers can have the same thing. So let's say std shared pointer person, and then we can just say person2 is equal to person1. So this shared pointer here is sharing the first pointer. So it's just like having two pointers over a reference to an object that is basically referencing. So this is like perfectly copying a pointer. And the above will get deleted automatically once all of the shared pointers have been deleted. So if this shared pointer is deleted and this shared pointer is deleted, then it will delete itself automatically. So when all of the shares are deleted, they are not being used anymore, we are good to go. So to give you an example, let's go and create another scope here. Now inside of this scope, let's create another scope where this person exists. So this here can scope into this one right here. This is global to this. Just like with a function. These are basically what we use for functions, right? So it's the same concept. Now let's see what happens when we run this. Person was created, person was destroyed. So it didn't destroy the person 2 times, it only destroyed the person once. Even though this pointer was destroyed, we can still use this. The person 2, let's say hello, and person 1. Say hello, because 2 here is just referencing 1. But 1 will stay alive until the very end, until the end of its scope and all of its other items have been deleted, which would happen automatically. You don't have to worry about it. If you run this, you get what you expect. This is a little bit of a complex topic. You will use it a little bit, but for the most part, when you use pointers, try to use these because they can be very useful and save you a lot of trouble in the future. And that's that. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next C++ tutorial.